You're listening to China Manufacturing Decoded from the Sofeast Group. Hi everyone, episode 291 of the podcast. Adrian hosting. Paul Adams, our head of new product development, joins me once again. Hello, Paul.
Hello, Adrian. How are you, sir?
Yes, I am well. How are you?
Extraordinary well, thank you. Very
Marvelous. That's excellent. And I trust that all of the listeners, everybody tuning in, you're all good as well. Paul, you were on the podcast a couple of weeks ago, and we were talking about when to kind of green light your injection mold tooling.
Yeah, correct. Yeah, you're right.
And keeping on with the injection molding direction, well, we're talking about this again. I did mention at the time that we'd get you back on to talk about polymer selection and a lot of the important information that anybody using polymers to create their plastic parts, enclosures, components is going to need to know. And it's an important context here because we've seen time and again that the wrong material selection can either make life really difficult or it can be an outright disaster. So today I really want to talk about some of the common polymers that we often use for our customers' products and are used in general, their features, and importantly, how to decide what's suitable for you. That's how this is going to go down, Paul.
Well, that sounds good, and I think that's a very nice follow-on from the tooling explanation that we discussed last time I was on some time back. So yeah, it's natural regression into polymers, and this is a really important thing to understand, Adrian, as you said, because it could be a hero to a zero and back to a hero within just like the selection of the right polymer. And it could be the best decision you've made or the worst decision made. Making the right decision on a polymer for a particular component and use is absolutely critical for the success of your product, let's say. You know, can you imagine sort of some of the polymers we've got, they are particularly designed for absorbing impact. Others are designed or are out there for high visibility. Others are totally the opposite of that. They diffuse the light for safety reasons. And getting the wrong polymer, you're just going to get the wrong result. Now, if you don't understand polymers, they are very, very technical components of the polymer itself is very complex. A piece of equipment, or not losing my words there, but you know what I mean? It's not an easy thing to get your head around. Okay, it's a chemical compound. That's what I'm trying to say. And trying to understand all the chemical compounds that go into making a polymer or a plastic is very difficult. Okay, particularly if you are not the expert in a particular field. Now, I'm not claiming to be the expert here, but I've got some experience which I would like to share with everybody, if that's okay.
Yeah, and don't put yourself down, Paul. We know that you are a huge lover of the plastic injection molding world and one of the first ports of call for us, definitely.
Well, yeah, you're right. You're not wrong. We had sort of a new piece of equipment delivered the other day, and I went rushing over there, and it was still on the back of the lorry. I thought, oh, goodness. I'd have said something.
650 ton injection molding machine.
Yep, something like that.
Exciting times.
Yeah, we'll get some videos of that sort of potentially later on during the week, so we can upload those for everyone to have a look at.
Yes, yeah, absolutely. No, that on our LinkedIn page for Agilian, guys, if you're listening. Right. So yeah, agree. Important to understand which polymers kind of are out there that are most commonly going to be encountered and and why we would use them. We already know that making the right selection is key. So what's the first polymer, please?
Well, I want to break this down as opposed to a first polymer, second polymer, third polymer, etc. I want to break them down into particular sections. So the first one I want to talk about is the workhorse polymer, as in like the go-to. let's say, and there's a few within this particular category. And the first one is ABS. Now, I've already said to Adrian before we started recording, I can't pronounce some of these things, so I'm not even trying. So let's call it ABS. Okay. Now, ABS is a very, very common polymer, and it's probably one of the most common polymers that we use in our facility to produce a lot of components for a plethora of end products.
Mm.
Okay. Generally consumer products and consumer electronics, but it doesn't stop there. And we're using ABS because it is a very, very good, what we call all-rounder. Okay. It is the workhorse of polymers. This thing gives you the best balance of strength, rigidity, impact, as well as a good surface finish. Okay. It does have limitations, right? And some of the limitations is poor UV and weather resistance. So if we're making a product for an outdoor environment, we wouldn't necessarily go with a pure ABS polymer. The heat resistance is not as good as some of the other polymers, so there's something else to be sort of careful of. We need to look at that. But it's some of the good applications would be, for example, like I mentioned earlier, is consumer electronics products, automotive trim, enclosures for various products, including the famous, dare I say, the Lego brick. So all of these products are very good all-round products used from the workhorse polymer. The next one I want to talk about in this in particular sector is PC or PCABS blend. Now, when we're talking about a blend, we're talking about two base polymers coming together to make the set of ingredients to get the final cake, let's say. So we generally refer to any polymer that has been mixed as a blend. Okay, so the PCABS is a very good improved properties over and above the ABS as it stands. Now, again, it's going to take on some of those properties from the ABS. In other words, it's got good impact strength. The heat does improve because of the PC has very good sort of heat resistance properties as well. The What else have we got? So we've got the surface finish is very good. Again, looking at some of the limitations, it's not as good as PC on its own or ABS on its own, but it's a general, very, very good, improved, let's say, overall property from the ABS. So the PC ABS blend, again, is a very good all-rounder to move forward into products like, again, the automotive dashboard, laptop housings, power tool bodies, amongst other things. Okay. So, and what I'm going to come on to this later, we can add additives such as flame retardant additives. But again, I'll touch on to this a little bit later on.
Yeah.
So the next one I want to talk about, Adrian, is what we call the commodity polymers, the cheap and cheerful polymers that are pretty much up there with respect to like the percentage of use that comes through certainly our injection mold shop. Now, the first one on the list I want to talk about is polypropylene or PP. Now, PP is a fantastic product. It's low cost, lightweight, is chemical resistant, is very versatile. It's used in a lot of packaging, living hinge. If you don't know what a living hinge is, go to your kitchen, have a look at your washing up liquid bottle. On the top there, you've got a flip cap. That flip cap has an integral, what we call living hinge, right? And that will never break, right? Unless you tear it, obviously. If you're using this time and time in, putting the top on, taking it off, on, off, it won't break. Okay. It can tear off, yes, but basically this is absolutely fantastic product for that particular application and so many other household goods as well. Polypropylene is, or PP is, one of my favorite sort of polymers out there because of that. And again, we can add additional additives in order to modify the mechanical properties of the outcome of the polymer. In other words, we can put things in like talc to make it stiffer. Polypropylene. I've got a case study about this later on, Adrian. So please remind me with respect to polypropylene products.
Yes.
One of the key limitations is very difficult to bond to. Okay, because it's got an inert in nature to it. So I'm just going to leave that one on the table. We'll pick that one up afterwards or later on as we go through this podcast. So come back to PP on why that is a bit of a pain with respect to bonding issues. But the best thing about polypropylene is that living hinge. It is fantastic. And you'll see this time and time again everywhere we go, particularly around all the supermarkets.
Yep.
You'll be looking out for this now. I've said it. I'll tell you.
Ketchup bottle everywhere. Yeah, absolutely.
Exactly. Yeah,
Cosmetic bottles, shampoo, it's all there.
Yeah. Yeah. And next time you go around the supermarket, if you're not too familiar with polypropylene, you will be. I'm saying because you'll be selling your. Do you know what this material is? This is polypropylene.
We'll hear your voice ringing in our ears, Paul.
You bet. I'll tell you. You bet. Right. Another one is sort of polycarbonate in the commodity polymers group, let's say, as polycarbonate or PC. Okay, commonly known as PC. This is really, really good for high impact resistant sort of applications. It is also well known for being transparent. Okay, so we have our what we call glass like looking objects made out of polycarbonate. Okay, it's also very good at heat resistance. And this is why we throw that in when we talked about a blend earlier on, when we were talking about our workhorse sort of group with PC ABS, because we're trying to modify the mechanical properties of ABS by adding the heat resistance and the other properties that come along with a sort of polycarbonate. Okay, so and again, a lot of these blends out there that suppliers work with are basically formulated in order to improve one or two of the mechanical properties of the base polymer. Okay, and this is exactly what PC does to ABS. So anyway, we are looking at a very, very good optical clarity polymer that can be used for day-to-day wear, spectacles, glasses, lenses, covers, light bulb lenses, and stuff like this. Now, also, because of the high impact resistance, it's also used for safety equipment. So on machine tools, for example, you'll always have a guard that you can see through, but if there's something that is thrown from the machining operation, and it hits or impacts the window you're looking through, it won't shatter. Okay, you're behind safe, what we call safe glass, which is polycarbonate.
Yeah, it's going to be on your motorcycle helmet as well, right?
But correct, yes, I have sort of probably too many crash helmets or motorcycle helmets hanging up on my wall. But so that's another story for another day. But yes, correct, correct. Another one in this group I want to talk about quickly is high density polyethylene, or HDPE, commonly known as. Another great product. It's really good for chemical resistance, this polymer. So it's a moisture barrier. And it's also, very importantly, food safe. Okay, so you'll get a lot of your takeaways or your products that are pre-packed on the supermarket shelf in HDPE or high density polyethylene trays that are wrapped up or whatever the case may be. That is all from the HDPE. A lot of it, not all of it, a lot of it. Okay. But it does have some issues. So it is low strength and stiffness, and it's poor temperature resistance. Okay. So make sure that we are, again, selecting the right polymer for the right application. Now, the right application for high density polyethylene would be going back to our living hinges. We've got the top needs to screw onto the bottle. So your bottle could be high density polyethylene. So this is really good for shampoo bottles, other packaging products, milk jugs, for example, chemical tanks, because the high chemical resistance properties this has is really good for that.
Mm.
So I think so. That's basically where we are on the commodity polymers, Adrian.
Yeah, talking about the HDPE for a minute. American listeners, I think it's different in the States, right? Or in North America for Canadians as well, right? But in Europe, I think that new legislation has come in which necessitates the bottle and the top to be kind of connected together now. So before you unscrew your top, which is probably a form of ABS, and then you have your HDPE bottle, but now the top stays connected. So on its little neck, it sort of hangs off, and that's kind of like a living hinge, actually. And it means when recycling, all of these different little bits stay together and they don't turn into microplastics as easily.
I've seen that. Yes, I have. Now, to be fair, I haven't been back to the UK for a while, but I have seen that.
Mm,
You're right.
yeah.
And I think that's a good thing. And I think I'm not sure where it came from, but there are some sort of quite sad and tragic sort of stories where infants are being managed to swallow the bottle cap. This will prevent that. So, which is a good move.
Mm.
I like that.
Yeah, yeah,
Uh,
absolutely.
so that's good. All right. So moving on to my favorite group, engineering polymers.
Mm,
Okay. This is where sort of the rubber meets the road, let's say. When we're talking about engineering polymers, this is where it starts to get a little bit sexy with respect to trying to choose the right polymer for the right products.
mm,
When you've got a technical solution to solve. Okay. So the first one, it's not so sexy to be fair, is nylon. Okay. Or the PA or the PA6 or the PA66 there
mhm,
are others out there. However, nylon is a fantastic product. Yeah, it's a brilliant polymer. And we're really looking at a number of different attributes that can be really put into the design when you're looking at a product and you think this is clearly a PA or a nylon, okay, because it has high strength, high stiffness, high wear resistance, and high heat resistance. So all of those attributes together make for a really good engineering polymer. So, we're talking about gears within gearboxes can be nylon, or a modified nylon. So we're talking about PA6 or PA66 because they are high wear. They've also got the inherent long wearability. Um, so it's really nice to actually have that option as opposed to, I need an expensive gear. I've got to go steel or I've got to go brass or whatever the case may be. No, no. Look at nylon as an option for your gears within your gearbox. You'll be
mm,
surprised at how good they actually operate.
mm,
So, which is cool. What else have we got from a nylon? We've got some downsides, clearly. Now, nylon does absorb moisture, right, which can affect the dimensional properties of the product. So you've got to be careful there. So if you've got an assembly or sub-assembly, we've got a number of different nylon parts going together, right, that is used in an outdoor environment. In other words, right, susceptible for the weather and the climate. In other words, moisture gets in. You will expect dimensional changes on the products. And if that's a critical fit, you've got to be very, very careful. So this is where you need to look at the selection of polymer you're using in order to work out what the end result would be if there's a failure because of. Now, one of the because ofs is moisture absorbent in nylon. Okay,
mm,
could mean that the 2 parts, 3 parts come apart and everything falls apart. So some of the things that nylon could be used on, I've already touched on sort of gears, which is a sort of a great application for nylon, bearings as well, other automotive products, and general mechanical products. You'd be surprised how many components are made out of nylon, so which is good. And
mm,
again, we can actually modify nylon with a number of different additives. And I think the biggest one that is used, or most commonly one, is glass fiber. Now, with the glass fiber additive, this makes this even stiffer, stronger, potentially the wear resistance will come down a bit because there's more sort of fibrous. But yeah, glass fiber is a very, very common additive to make the general baseline of the nylons properties be improved or increase. So, which is great.
Mm.
Right, let's move on to the next one. I've got a couple here, which is POM or acetyl, which is a brand name. Low friction. Low friction. This is the big one for POM, really, in my mind, when I'm looking at sort of a product where I've got two components moving against each other. I would always come back to POM as a product. It's very low friction. It's high stiffness as well, so which is great. So therefore, it's got excellent fatigue resistance. So if you've got a product that is in that type of application, don't go with anything else apart from POM. Okay, so let's have a look at some of the negatives or the key limitations. It's very poor, not very poor. It is poor resistance to strong acid and bases. Okay, so you've got to be careful with respect to using that inside sort of various different products which are using acids or a base. Okay, so I've got to be careful of that. However, looking at that as a high stiffness, low friction polymer is fantastic for precision gears, conveyor belts, fasteners, zippers, and fuel systems.
Mm.
So I wish I bet you didn't realize.
Would you say that choosing components made from POM, for example, would be cheaper than having them made from machined metal?
Again, you've got to look at the actual application of the products or the two components that are matching each other. Now, you could have a combination or a hybrid, Adrian, where it's got one part is metal, one part is POM, for
Mm.
example. But if you're having everything as POM, inherently it would be cheaper because you can, from a component point of view and a scalability point of view, it would be cheaper having an injection molded part as opposed to, say, a million machined components.
Sure.
Okay, versus a million injection molded components.
Mm.
Now, we know, and we talked about this many, many times, there is the inherent upfront cost with respect to getting that injection mold tool built and paid for. Whereas there's
Mm.
zero investment in machining upfront, but the machining part cost is infinitely more than your injection molded part. So your ROI would sort of soon break even
Mm.
and surpass that of any machine parts
Interesting.
for
Okay.
sure. Another one that I want to talk about here is something that we've started to use and use quite a bit on a number of different products is Tritan. Tritan's the brand name. This is PCTG. I'm not even going to pronounce that. But Tritan is it's a thing. It's a thing. If you want to search up Tritan, please do. It's a thing, and you'll be surprised on what you see. It's basically like glass.
Yeah. Yeah.
Okay, so you'll see many, many, many bottles out there look like glass, but they're branded as this is made from Tritan, and it's a good thing because Tritan is highly transparent. It's brilliant from a transparency point of view. It's very strong, right? It's tough material. It's BPA free. It's FDA approved. If you get the right supplier with your own polymer, it'll be FDA approved. In other words, it's very good for food, drink, and other containers that are used in that particular field.
Mm.
We've started to use this quite a bit because we are producing a number of components that go into food grade or FDA approval required products, and Triton fits the bill. Now, one product we've got is it contains a number of Triton, let's say, bottles, for lack of a better term, without giving the product away. Initially, we had this as highly transparent. Okay. But now we've gone over to a deep royal blue as a Tritan bottle, right? And this thing looks fantastic. It really does look good. And it does that for a number of reasons. I can't give you why, because I'll give the product away, but it's really, really good. So it does come as transparent, but the thing is, you can have it in different colors. Okay, you can have it in any color you want, but inherently, this has very good transparency. It's excellent impact and chemical resistance. However, we already talked about polycarbonate as being the go-to lens polymer. Now, the downside of using Tritan, because of its FDA and food grade and other things that are associated with it, it is a little bit more expensive than your standard PC or polycarbonate. But you will see it is a trending thing right now at the moment with a lot of bottles out there, including medical devices, baby bottles, and small appliances and various different drinkware that you can see left, right, and center wherever you look. So Tritan is a thing, and we are very, very happy that we are using it.
Yeah, that's an interesting polymer there. So if we get back to, you were talking about PP earlier, and you mentioned that you'd actually got an example of this. And what's helpful, I think, to kind of illustrate what happens when you're selecting materials, in this case polymers, and maybe if you're selecting wrongly, what's the impact of that? What better than to go through a real example? And I believe PP was in play here.
I'm glad you brought that up. Yeah, so I had forgotten. So this is a real life case study. I should change a few things, and obviously to keep IP sort of closed.
Yep.
Without giving anything away. But there's two components. Originally, both components were ABS. Let's say these two components need to be glued together. Okay, put it in simple terms. They need to be glued together, structurally sort of bonded together, and they need to be bonded together for a long time. Okay, for the length of the product's life cycle. However, one part was, when it was molded, didn't quite match the other part. So in other words, you've got two mating parts. Okay, now without and these are big parts, big components, maybe 2 foot diameter. Okay, so which is a really, really big tool when it comes to consumer electronics. Instead of modifying the tool, which would have taken a considerable amount of time, in other words, delayed the product build because this product was going into pre-production, and some cost, obviously, in order to do to get the sort of the mating part matched up. So what they done instead was changed one part from ABS to polypropylene, PP. Now, we've already made the claim that PP has difficulties when it comes to a bonded surface. Okay, so what I'm not telling you is what's being bonded. It's not the two parts I've been talking about, but it's a separate part inside the part that was changed from ABS to PP. Okay, that was still ABS. Now, when they come to pre-production, it was like rush, rush, rush. Come on, let's go, let's go, let's go. Mm-hmm. So we thought, oh, it's not sticking. We've got a problem, and we've got, let's say, 100 units to build. We've got a problem. We're just into a sort of pre-production stage, and it's not working. This third component is not sticking, let's say, to the polypropylene, whereas it used to stick to the ABS, no problems. And all of the tests and everything like this was done on the previous version, which was ABS to ABS, and everything was perfect. But now one component was being put to the test because it wasn't sticking. So we had a major problem, and we still had to go through the root cause analysis. So what happened? Why isn't it sticking? And it wasn't until we actually realized that, hold on, let's go back and have a look at the polymer characteristics of each of the components to work out what's going on. Right? And once we realized that, oh, hold on a minute, this is now polypropylene. Polypropylene is an inert material and is renowned for having a poor bonding property to it. We need to do something about it. So therefore, we had to change the material back to ABS, make those tool changes, right? And now everything's perfect. Okay. So the rush decision with respect to, I don't want to spend time changing the tool. The cost was neither here nor there. The customer was happy enough with the cost, but it was the time impact in this particular case that drove the decision to change the polymer without testing or validating what that change would impact.
Mm.
Now, in this case, it meant a failed product because
Mm.
that bottom product, call it item number one, was the whole base of the unit. Item number two, the item number one was changed from ABS to PP. Well, item number two was the next part of the subassembly, and then we had another 25 components built on top of that. Okay? So it was the very, very start of the build process that threw everything out.
Mm.
So, lesson here is don't rush in. Make sure you do your analysis in order to make sure that you're choosing the correct polymer. And if you change your minds halfway through a build, you need to calm yourselves down and still do analysis with respect to, am I choosing the correct polymer for the right application?
Yeah.
Yeah. And in this case, yes, it worked because polypropylene has a different shrinkage rate in the injection mold tool than ABS does, and it cured the aesthetics look, let's say, of what we're going for, but it had a major impact for the rest of the build.
Yes. Looks can be deceiving based on what you're
Ah,
saying.
exactly. Yes,
Mm.
that's right. Don't rush in.
Okay.
Make sure you understand what you're doing.
That
So,
it's good to have that real example as a touchstone and sort of put what the knowledge that you're sharing about these polymers, sort of show it in practice. So yeah, I like that. Now, something that we've been working on recently is more sustainable polymers. I know for one of our customers, we've been producing some bioplastics, I think is what they would normally be called, right? So I think you'll talk a bit about those now.
yeah, the sustainable side is a bit of a strange one, really, but really interesting. Now, in here, we've got stuff like, TPE, TPU, which is the flexible stuff. But the really interesting one is something that we've been working with for a year or so, and
Mm,
it's going really, really well. And which is
mm,
PLA, or PLA. I'll try and pronounce this as a polylactic acid.
mhm.
Now, the interesting thing about this is it is a biodegradable polymer.
Yeah.
All right. So basically what we're looking here is, let me break it down a bit. Okay. Yes, it is a polymer base, but is a percentage polymer where we are looking at additives such as coconut fibers. Okay. So this makes it the biodegradable. We've also got one that we are using with coffee grinds, believe it or not. Now, all of this makes it, what? You're injection molding coffee grinds? Come on, Paul, get real. Well, actually, we are. But it's not just the coffee grinds we're injecting molding, clearly. It has to come with a polymer base. Okay. So that polymer base then has the additional material in. In other words, what we talked about earlier, a blend. So the blend here is the polylactic acid as the polymer. Then we are adding various different fibers in order to make that polymer a biodegradable
Mm,
sort of products, which is really, really important in some applications. Now, this comes with a massive caveat with respect to there are there are probably more limitations than there are benefits when it comes to this from a mechanical property point of view. Okay, stress that again. From a mechanical property point of view, there are more limitations than there are benefits. However, yeah, from a sustainability, wow, I think we nailed it. We're right up there. Now, key limitations here. We are looking, this can be a very brittle sort of product when it's made. Yes, it has low heat resistance simply because of the additives we're putting in there. Is it good for the environment? Yeah, for sure. It is. Yeah, it's a lot better than most of the other pollens we've talked about. And what's this good for? I bet a lot of you, I don't know what percentage, a lot of you have already used disposable cutlery, okay? Packaging that is biodegradable,
Mm.
3D printed filaments, okay? All of these things that we are actually experimenting with and producing for some of our customers right now. And I think the biggest one has been the PLA with coconut fibers. Fantastic. It's this is a game changer. Yeah, when it comes to sustainability and biodegradable, if you want to produce a product that can be environmentally friendly as well as economically viable to produce from an injection mold point of view,
Mm.
have a look at PLA.
Yeah.
Okay. Now, one of the things, without giving too much away, one of the things that we are producing is, let's say, for seedlings. Okay. Now, we've all been down to the garden centre. We've bought our sort of little moss trays and things like this. You put your seeds in and you just plant the whole thing and away you go. Same thing with this.
Mm.
Exactly the same thing, but just done in a slightly different format. So that is really, really interesting. It's something that I'm very, very sort of keen to explore a
Mm.
lot more with a lot more customers. So I think that'd be really good.
Yeah, there's definitely a push to use less oil-based plastic. So yeah, the demand, I guess it's only going to go up and up.
Yep, absolutely. I think so.
Mm.
We're certainly seeing sort of more people asking about it, sort of from our end, so
Mm.
which is good.
Mm.
Oh, another thing that I want to talk about, Adrian, before we sort of close down here is the
Yes.
additives. I've been talking about additives sort of throughout. It's just sort of one thing I just want to finish up on. Now, when it comes to some consumer electronics, let's call it a product in the kitchen. Okay. In order to sell that product, right, your particular product regulation for UL, whatever it is, they may stipulate that you have to be compliant with UL, blah, 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 and everything must be flame resistant or flame retardant. Well, if you're making your product out of plastic, we all know plastic burns. Okay. However, we can add additives or modifiers to the polymer in order to make it flame retardant. Okay, so this is one of the big things. Apart from modifying the actual mechanical properties, where we talked about glass fiber, long fiber, short fibers earlier, which improves the mechanical properties, we can also add flame retardants in there. Now, another very, very popular additive or modifier is UV protection. Now, again, this is commonly used on products or components that are being used outdoors, obviously, where they need to remain outdoors and exposed to the elements for a long period of time without discoloring, without changing the mechanical properties. In other words, going from a tough material to a brittle material that breaks, then exposes the electronics inside and it exposes hazards. That's no good. So we add in UV protection modifiers to the actual raw polymer itself. So, which is really important. So we can modify the mechanical properties. We can improve the sort of strength, stiffness. We can also improve flame retardant by adding modifiers and fillers. And keep your product intact from a UV protection point of view. Okay, just as a round, sort of broad brush, holistic view from what we call talking about additives earlier. I just want to add that one in.
But important though, because it almost, because it transforms what you're doing, and so could be very important. So yeah, I get the importance of mentioning those. So if we wrap up now, what are the takeaways that the listener should be taking away from what you've been talking about then?
Well, I think the main key thing, takeaway is don't go with your, off the top of my head, the only one I know is ABS. So therefore that should fit everything.
Right.
Okay. Which, to be fair, as a young, sort of 26-year-old engineer, that's what I used to do. It's the only thing I knew. But that's so wrong. You really, really need to understand not the polymer, but the properties the polymer needs to provide. Okay. So we're looking at functionality, strength, flexibility, heat resistance. You're looking at safety compliance. Does it need to be flame retardant, food grade, BPA free? Okay. You're also considering cost and availability. Yeah, some of what we talked about earlier, the PLAs, are they commonly available in every single country, in every single town? Potentially not. You need to consider all of these aspects. Sustainability. Do you really need that PLA that we're talking about with the coconut fibers? Maybe you do. So all of these aspects are not one polymer fits all. Okay, that is far from the truth. So as a young 26-year-old, the only thing I know is ABS. ABS is like the king. Well, no, not quite. Okay, one size does not fit all when it comes to polymer selection. Okay, that's the first thing. And the other thing is, make sure you get the data sheet in order to cross-check what I just talked about. Okay, your functionality, your safety, your cost, and your sustainability goals. Double check, do your homework, do your due diligence with respect to what the data sheet does. Okay, and the last one is, if you're not sure, test it. Okay, PP, yep, it's great, but I need it to be glued together. Test it. Okay. That's all I have to say on that.
No, that's absolutely great. That's perfect. Never forget the importance of testing. I mean, it's something that we talk about almost every week on the podcast in different ways, right? I think in a future episode, Paul, perhaps we might talk about polymer processing methods, because that's kind of a logical follow-on to this. Would you agree?
Oh, don't get me started on that. Yeah, let's go.
Not right now. Hold your horses, right? So
all right.
Future,
yeah.
for a future episode. So we're talking about the obvious one is injection molding. However, there are more, and depending on which method you use, that's going to influence the performance of what actually you end up with. So I think, definitely worth looking at that, because again, this is something that we actively do for our customers. Paul, it's been a pleasure, really helpful.
Thank you, sir.
And do get in touch with us if you've got any questions about polymer selection with regards to your project. We'll be really happy to help. We'll be back next week. Thanks for listening. Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.